Okay, so for lesson 7.2, you're going to be learning how to find the confidence interval and sample size when the standard deviation for the population is not given to us. So when finding confidence intervals, with unknown standard deviations, our distribution becomes a t distribution. Now, some properties for the t distribution. So again, this is only if our standard deviation is not given to us. So some of the properties for the t distribution is it is bell-shaped. So it is like the standard normal distribution. It's also symmetric about the mean. So the mean is right in the middle. Something else that we know is that the mean, median, and mode are 0. The variance is greater than 1, so this one's different than the standard deviation, the standard normal deviation. So the variance is greater than 1. So the next one is based on concept of degrees of freedom. I'm going to go ahead and explain that a little bit right now, but the t distribution is based on the concept of degrees of freedom. So we're going to learn this new definition right now in regards of what are degrees of freedom. And the last one is that as the sample size increases, the t distribution approaches the standard normal distribution. So the greater n, the greater that the value of n, then the more that the t distribution will approach the standard normal distribution. So now let's go ahead and talk about definitions. So the degree of freedom, so this is when we're going to talk about the definition of degree of freedom. So the degree of freedom, degrees of freedom, are the number of values that are free to vary after a sample statistic has been computed. So yeah, so these are all those values that are pretty much free to change, to be different after the statistic has been computed. So it's pretty much those values that are not restricted to whatever statistic that we're doing, right? So those are known as the degrees of freedom. Now to find the t values, for the t-distribution. So these look like this. It's basically like the z-values that we're working with. We're gonna use the table F on Appendix A. So for these ones, we do need to look them up on the table on the back of the book. If we don't, again, if we don't have the standard deviation given to us, so we do need to use the table in the back. We don't have specific values like with the Z where, for a 90% confidence interval or for a 95% confidence interval. For T, we do need to go ahead and look up the values because we can be given different different values for the confidence interval, plus our t values can change depending on the problem that is given to us. So we do need to use F, and also our t depends on the degrees of freedom, so that's the reason why we need to look up at the table, right? And we cannot only use one set of values like with the standard normal distribution. So now let's go ahead and go over the formula for our confidence interval when the standard deviation is not given to us. Let's get rid of this. So to find the confidence interval for the population mean, and again the standard deviation is unknown, we use the following. So I'll do it in red. X minus t, the t value, times s. So s is the standard deviation, but for the sample, not for the population. So that's one of the things that you'll notice. There is a difference between having the standard deviation of the sample and then the standard deviation of the general population, right? In this case, the one that's not given is the standard deviation for the population. And then here, degrees of freedom can be found by subtracting 1 from the sample size. Okay. Now there's two assumptions that we're going to be making again. So in order for us to be able to use this formula, there's these assumptions that we need to make. The first one is that the sample, it's a random sample. And the second one is again that the sample size is greater or equal to 30, or population is normally distributed when the sample size is less than 30. Okay. So these are the two assumptions that again we're going to be making in order for us to be able to use this formula and for us to find the confidence interval when standard deviation is not given for the population. Let's go ahead and work on a couple of examples. I'm going to go ahead and erase this. And let's see what this first exercise says. So it says a random sample, so it's random, that's good, of 10 children found their average growth for the first year was 9.8 inches. Assume the variable is normally distributed. And the sample standard deviation is 0.96 inches of an inch. Find the 95% confidence interval of the population mean. For growth, during first year. So we have these 10 children and they noticed that their average growth for the first year was 9.8 inches. They want us to assume that the variable is normally distributed. Reason why we're assuming this is because our sample size is pretty small. It's less than 30, it's just 10, right? So we need to assume that it's a normally distributed population. And then it says that the sample standard deviation is 0.96 inches. And they want us to find the 95% confidence interval of the population mean for growth during the first year. So again, step one, let's go ahead and list down our given information. So for given, we have our sample mean, which is 9.8 inches. Then we are also given our sample standard deviation, which is 0.96 inches. Then we are also given our sample size, which is 10 children, right? And they're also giving us that the confidence interval must be of 95%, which if we look at the table F, it seems that T is 2.262, and again this one having a degrees of freedom of 10 minus 1, so df, degrees of freedom, is 10 minus 1, which is equal to 9. So this you look at table F on the back of the book on appendix A. So we have everything that we need. Step 2 is to plug in the values. So our formula is x bar minus t alpha 2 times s over square root of n less than the population mean less than x bar plus t alpha 2 times standard deviation for the sample over the sample size, the square root. So let's go ahead and plug in the info. We have 9.8 minus 2.262 times 0.96 over 10, the square root of 10, less than mu, less than 9.8 plus 2.262, 0.96 over the square root of 10. So if we plug that in the calculator, we get 9.8 minus 0.69 less than mu less than 9.8 plus 0.69, which is going to give us a 9.11 less than mu less than 10.49. So then, with a 95% confidence, we can say that the population mean of the first year growth, is between 9.11 and 10.49 inches. And we're done on how to finding the confidence interval for a situation where the standard deviation of the population is not given to us.